Welcome to the tutorial of K-map. In 1953, the American physicist Dr. Maurice Carnot invented a form of logic diagram called a Carnot map. It provides an alternative technique for representing Boolean functions. In K-map, each entry of the truth table is filled. How it is done, we will see in the next slide. Before studying the K-map, let us first understand the entries of the truth table, how truth table can be written in the form of different equation, what is the meaning of SOP, meaning of POS, what is the meaning of minterm and maxterm. After studying this, then we will go for the K-map. For an example, we have taken the XOR gate truth table. It is two input XOR gate. A and B are the inputs, Y is the output. The input combinations decimal equivalent I am writing on the left hand side 0, 1, 2, 3. The output column Y is consisting of 0 and 1s. The output column can be converted into a SOP equation or into a POS equation. What is the meaning of that? Let us understand. In the output column, we are having 1 for two entries, for this and this. This one output is represented by input combination A bar B. Bar we are writing for 0 and no bar we are writing for 1. We are having 1 here also. So we are writing the term like this. So truth table can be written in the form of equation like this. Y is equal to A bar B plus AB bar. These terms are known as minterms. And this equation is known as SOP, that is sum of product. This equation can be written in the form of minterm also. Meaning is, this is the truth table having two variables, so it is written function of AB. Minterm means we are going to write the decimal equivalent for the entry. So there are two minterms, so we are writing summation of minterms. Minterm is written in the small m. Inside the bracket, we are writing the decimal equivalent for those terms. So this is 1, 2. So what we have understood that truth table can be written like this or it can be represented in the form of minterm. Similarly, truth table can be represented in the form of zeros. Now we are having 0 in the output column here and here. While writing the input combination for this, the process which is adopted, it is like this. When we are seeing the zeros, so it is written as A plus B. Here for 0, bar is not put. For this 0, input combination is 1, 1. So it is written as A bar plus B bar. So for 1, bar is put. So output column Y is represented as A plus B into A bar plus B bar. The two terms which are there for zeros, they are known as max terms. And this equation can be represented in the form of max terms like this. Here summation symbol is this and max term is represented by capital M. And inside the bracket we are having 0, 3 because 0 is for this 0 decimal and this 0 is for this 3. So truth table is converted like this. This type of equation is known as POS. So in nutshell we can say any truth table can be converted into the SOP equation or into the POS equation or in the form of minterms or in the form of max terms. Once we understood this, now we can go for K-map. K-map is basically a graphical tool which has the entries of the truth table. Now in this truth table we are having the two inputs. So we are going for the two variable K-map. So it is shown here. We are having 4 boxes in the K-map. each box is for each entry. We are having two input variables. We are writing here A and B, and we are having the combinations. So A can take value 0 or 1, B can take value 0 or 1. Now see, for this 0 0 combination, output is 0. So 0 0 combination is this is 0, this is 0. So this is the square for that. So output is 0. For 0 1 combination, so this is 0 1 combination, output is 1. For 1 0 combination, output is 1. And for 1 1 combination, output is 0. This is how K-map is filled. Now, these decimal equivalents which are shown in the truth table, we can write them in the K-map also. So 0 0 is represented by 0. So this is 0, this is 0. So this is represented by this 0 decimal equivalent. 0 and 1, it is represented by 1. So I am writing here 1. Obviously this would be 2 and this would be 3. So K-map filling for two variables is done like this. We can make K-map for more than two inputs also. That depends on the truth table. We can make it for 3 input, we can make it 4 input, we can make it for 5, 6 and so on. We can make it for n variables. But at the most 6 variable K-map is used in practice, because after 6 variables it becomes very cumbersome. We will see how K-map is simplified in the next slides. Let us see how to fill K-map for 3 variables. 3 variable truth table is shown on the slide. Let us write down the decimal equivalent for the binary input combinations. So this is 0, 1, 2, 3, 4, 5, 6 and 7. Let us write the SOP equation and POS equation for the truth table. So let us write first SOP equation. So for SOP equation we will see the entries of ones and we will write down the minterms for that. So it would be A bar B bar C plus A bar B C bar plus A B bar C plus AB C bar plus ABC. Let us write down that in the form of minterms. So function of ABC. Now there are 3 variables. Summation of minterms, and we will write down the decimal equivalent for those ones. So this is 1, 2, 5, 6 and 7. So 1, 2, 5, 6, 7. So this is what is the SOP representation. Let us write down the POS representation. So y is equal to, we will see now the output column for zeros. So I will write A plus B plus C in the first bracket. Second bracket would be A plus B bar plus C bar, and third bracket for 0 would be A bar plus B plus C, and in the form of max terms it would be summation of max term and decimal equivalent for that 0, 3 and 4. Now let us see how to fill the K-map. Now this is 3 variable K-map. 8 boxes are shown and each box is for each entry in the truth table. In truth table we are having the 8 entries, so there are 8 boxes in the K-map. Now this is, we are writing AB and this is the third variable C. C can take values 0 and 1, and let us see carefully how AB sequence is written. AB is written as 0 0, 0 1, 1 1 and 1 0. This sequence which is shown there, this sequence is known as gray code. We have seen in truth table input values typically follow the binary sequence, but in K-map values follow the gray code sequence. In gray code, values of adjacent rows vary by only single bit, and in K-map simplification, grouping of adjacent ones and zeros are done for reducing the variable, And due to gray code, groupings can be easily done. In gray code, each row vary by single bit. What is the meaning of that? You see the sequence. Here from 0, 0 to 0, 1, 0 is remaining as it is, this 0 is remaining as it is, and this 0 is becoming 1. So only one bit is changing. If you go from this to this group, 0, 1 is changing to 1, 1. So 0 becomes 1, but 1 remains as it is. So again single bit is changing. From this to this, if you see, 1 remains as it is and only 1 is becoming 0. So again single bit is changing. So that's why gray code is used in the K-map. Now let us fill the output column. For 0, 0, 0, from the truth table you can see 0, 0, 0 output is 0. So here it is 0. We can write. For 0, 0, 1 we can write 1. 0, 1, 0 we can write 1. This is 0. Now this 1, 0, 0, here it is 1, 0, 0. We are having 0. 1, 0, 1 is 1. This one and this one. Now what are the decimal equivalent for the boxes? See, 0, 0, 0 is here 0, 0, 0, 1 is 1, 0, 1, 0 is 2, this is 3. Now let us see carefully. This is 4, this is 5, this is 6 and 7. So decimal equivalent sequence you have to be careful because of the gray code. This is how K-map is filled for 3 variables. Let us fill quickly the K-map for 4 variables. We are having 4 variable truth table. Let us write down the decimal equivalent for the input combinations. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. We can write the SOP equation as well as the POS equations. How to write we know from the previous slides. I will write the equation in the form of minterm. So function of A, B, C, D, because 4 variables, in the form of minterms. So we are going to see the entries of 1 and their decimal equivalent. So these are the entries in the output column of ones. Now here I will write 1, 2, then 5, 6, then we are having 8, then we are having 10, 13, 14 and 15 inside the bracket. So I will write 1, 2, 5, 6, 8, 10, 13, 14, 15. Similarly, I can write the equation for POS in the form of maxterm. So that is summation of maxterm. I will see the entries of zeros. We are having it here, we are having it here, here, here and these two, right? So I will write this 0, 3, 4, 7, 9, 11 and 12 inside the bracket. So 0, 3, 4, 7, 9, 11, 12. So this is my SOP, this is my POS. Now let us see how to fill the 4 variable K-map. Now here I will be having variables AB, here it will be CD. We know the sequence, that is a gray code 0, 0, 0, 1, 1, 1, 1, 0. Here again 0, 0, 0, 1, 1, 1 and 1, 0. Now if you see the numbering in the form of decimal equivalent, it will be 0, right? 0, 0, 0, 1 is 1, 0, 0, 1, 1 is 3, this is 2. This will be 4, this will be 5, this will be 6 and this will be 7. This will be 8, 9, 10, 11 and this will be equal to 12, 13, 14 and 15. These are the decimal equivalents of the boxes. Now from this we can straight away fill ones, or if you want to fill zeros you can fill it from this. So where I will be putting 1, I will be putting 1 in these squares. So this is 1, this is 1, this is 1, 6, 8, 10, 13, 14, 15, and remaining boxes are zeros. So this is how K-map for 4 variable is filled. K-map is used to simplify Boolean expressions. It can be SOP equation or POS equation. The first step in simplifying is grouping. If we make a group of two adjacent ones or zeros, it is known as pair. It eliminates one variable and its complement. If we make a group of four adjacent ones or zeros, it is known as square. It eliminates two variables and its complements. If we make the group of 8 adjacent ones or zeros, it is known as octet. It removes 3 variables and its complements. We can also roll the map to reduce the variables. We will see how grouping and rolling is done of the map in the next slide. Let us see how grouping is done in two variable K-map. See the first two variable K-map we have filled with zeros and ones. How grouping is done in this K-map? Let us see. We are having two inputs A and B. So this is your A bar A. This is B bar B. Now these two ones are adjacent to each other. So we can make a group of it and it is known as pair. See the second K-map. Again it is a two variable K-map. This is A, B. This is A bar A, B bar B. Here again two ones are present which are adjacent to each other, so we can form the pair of it. See the third one, we are having A, B. This is A bar A, B bar B. Here once they are diagonally adjacent to each other, so we cannot form the pair. If they are vertically adjacent or horizontally adjacent, we can form the pair. See the fourth K-map. Here we are having inputs again AB. This is your B bar B. This is your A bar A. Now these two ones are vertically adjacent, so we can form the pair. And these two ones are horizontally adjacent, so we can form the pair. See the fifth one. Here we are having again AB. This would be A bar A. This would be B bar B. So these two ones can form a pair, and we can have pair like this also. And see the last combination. Here your K-map is filled with all ones. So this is A bar A, this is B bar B. So here four ones one another, so we can form a quad out of it. This is how the grouping is done in the two variable K-map. So how to write the answer for each K-map? Let us see quickly. Now these two ones, they are adjacent to each other. Now see these two ones, they are present in the column A and in the rows B bar and B. If you go from one square to the next square, so B is changing from B bar to B, so that has to be removed. So what is remaining is A. So answer for this pair is A. Apply the logic for the second K-map. See here these two ones are adjacent. They are in the row B, but columns are A bar and A. So A is changing. So answer for this K-map is B. This pair is not allowed. Now let us go to the fourth one. So here we are having the two pairs. So answer for this pair is A and answer for this pair is B. So it is written as A plus B because it is SOP equation. We are grouping ones. Here Now it's very easy to write the answer. Answer is A bar for this pair. Answer is B for this pair. Now see this one. Here all the squares are filled with the 1. Then answer for this type of filling is 1. How it is 1? If you form the two pairs, which we cannot form because normally we go for the higher groups. That means if quad is possible, then form the quad, not the pairs. But to prove how it is y equal to 1, let us see. For this pair, answer is A bar. For this pair, answer is A. According to Boolean expression, A plus A bar is equal to 1. So if all ones are present in the K map, answer is 1. We will see now grouping of ones in the 3 variable K map in the next slide. How grouping is done in 3 variable K map. Let us see the first example. We are having 3 variable K map and ones are entered as shown. Now if you see, we can make two pairs in this K map. So this is pair number 1 and this is pair number 2. Then what is the answer for this K map? So if we want to write the answer, now see these two ones which are adjacent to each other, they are in the column AB and they are in the rows C bar and C. So what is changing? C is changing. So answer for this pair is AB. Similarly, if I want to know the answer for this pair is A bar B bar. That is what is the answer for the first K map. Now let us see the second one. Here ones are entered like this and we want to find out the answer. In K map, always keep it in mind that try to form the larger group. That means in this case I can form the two pairs, but I will go for the quad because 4 ones are adjacent to one another. So here this is a quad. Now how to write the answer for the quad? Let us see. So y is equal to, now see these ones, they are in these two columns and they are in these two rows. So C is changing, so C will be removed, and here A bar is becoming A, so A is also removed. So A and C are removed, so only remaining variable is B. So answer for this K map is B. See the third case. Here ones are entered like this. Again, now here we can say this is a quad of 4 ones which are adjacent to one another. Now what is the answer for this quad? Now say it. Here these ones, they are there in this first row and they are present in all the columns. Now if you see it properly, B bar is becoming B, so B is removed, and A bar is becoming A, so A is removed. So A and B variables are removed, only remaining variable is C bar. So that is the answer for this K map. See this case, here now again two pairs can be formed. Now these two pairs are like this. This is one pair and this is another pair. So answer for these pairs are, now here you can see for this pair A bar is remaining as it is, but B bar is changing. So B will be removed and C bar is as it is. So answer would be A bar C bar for this pair. Plus for this pair, now you can see these two ones, they are in these two columns where B is changing. So B is removed and A and C are kept as it is. So this is the answer for this K map. Now let us see this K map. Now in last slide we have seen if all ones are entered in all the blocks, so this ones are encircled like this, and answer for such type of K map is 1. Now see the next one, and here where we will understand the concept of rolling the map. Now what is the meaning of that? Let us try to understand. If you see at the map, what you will find, you will be forming the two pairs. So this is one pair and this is second pair. But if we roll the map, we can form the quad. And quad is better because it removes more variable than the pair. How to roll the map? Now, meaning is we can roll the map from top to bottom or left to right or right to left. Here, this is my column AB bar. This is my column A bar B bar. Now, if I roll the map, that means if this column AB bar comes near to A bar B bar, now you see these two columns. Here, A is changing, B bar is remaining as it is. Okay, while rolling the map, what we are doing, see, rolling is shown like this. So we are rolling the map and we are trying to form the quad. Now quad is becoming formed. So here A bar is becoming A, so A is removed. So B bar is remaining, and here all the ones they are present in this C bar and C. So C is also removed. So answer for this is B bar. This is what is known as the rolling. Now let us see this K map. Here again we can roll the map and form the pair. Now see how to roll the map. Now these two ones, if they are rolled, they can be adjacent. So if I roll the map here, now you can see this column has got A bar B bar, this column has got A B bar. So A is changing, so remaining is B bar. So answer for this is Y is equal to B bar and C bar. So this is what is the meaning of rolling of the K map. You can see this one now. Here we cannot form the pair, we cannot roll the map, because even if we roll the map, these two ones they will not be adjacent to one another. So here neither pair is formed by, or even if we roll the map, we are not getting any reduction in the variables. So these two ones will be as it is and they are isolated ones. So answer for this K map is Y is equal to A bar, B bar, C bar for this, plus Y, that is answer for this one will be A, B bar, C. Now see the last K map. Now here again by rolling the K map we can get the pair. Here we can roll the map and these two ones they come to, or they become adjacent. And now if we want to write the answer, now see this A bar is changing, so B bar is remaining. So answer for this is Y is equal to B bar and C. So this is how grouping is done in three variable K map, and this is how rolling is done in the three variable K map. In the next slide we will see the four variable K map and grouping in it. Let us see four variable K map and grouping in it. This is the four variable K map. In this ones are entered already. What we are finding here, there are three pairs in it. This is pair number 1, 2 and 3. So answer for these pairs, it is written like this. For this pair, A is changing, B is remaining as it is, so B I will take it from columns, and from row C bar D, plus for this row from these two columns B is changing, A is remaining as it is, so answer is A C D bar, and for this particular pair D is changing, column remains as it is, that is A bar, B bar, and this is C. This is the answer for the first K map. Let us see the second one. If you see the K map here, these four ones they are adjacent to one another, so we can form the quad. So answer for quad, it is written like this. So here in these two columns, A is changing, so A is removed, and here C is changing, so C is removed. So answer is BD. Let us go for the third one. Here 8 ones are adjacent to one another, so we can form the octet. Now see here, in all the four columns variables are changing. A bar is becoming A bar is becoming A, and B becomes B bar, B becomes B bar. So A and B variables are gone. Here C is also changing. So only one variable which is not changing is D. So answer for this K-map is D. See the fourth K-map. Here we can roll the map and get the answer. Here these four ones, they can be rolled and they can become the adjacent to the first column. Now you see these two columns. Here A is changing, so it is removed, and from rows C and D both are changing. So only remaining and which is not changing is B bar. So answer for this K map is B bar. See the fifth one. Here again we can roll the map and get the answer. So these two ones are rolled from bottom to top. Here we can see these two rows. Here C is changing, so that is removed, and here A is changing, so it is removed. So here B is not changing, so Y is equal to B, and here D bar is not changing, so it is BD bar. See the next one. Here in this K map, these four ones are adjacent to one another, so it is forming the quad, and these two ones can be rolled to form the pair. So answer for this quad is, here A bar is changing, so A is gone, and here D is changing, so D is gone. So answer for this quad is B C plus more. Now for this pair, now see these two columns. So A is changing, B bar is remaining as it is, and this row is as it is, C bar, D bar. See the next K map. Here we are getting two quads straight away. This is quad number 1, this is quad number 2. Answer for this quad is, so A bar is remaining as it is, B is changing here, so this is gone, and here D is changing, so D is gone. So A bar, C bar is the answer for first quad. Here in this quad, A is remaining as it is, and here C is remaining as it is. So this is the answer for this K map. If you see this one here, now see here we can form the pair, and these two ones we cannot form the pair or any other combination, so they are isolated ones, so they have to be taken separately. So answer for this is, for this one answer is A bar, B bar, C, D bar, plus for this one answer is A bar, B, C, D, and for this pair A is remaining as it is, so it is written B is gone, here C bar, D. So this is the answer for this K map. And in the last K map you can see, here we can form a quad and we can form the pair. So answer for the quad is, in all these rows all the variables are gone. Here answer for this quad is A bar, B. For this pair now, here C bar is becoming C, so C is gone, so D remains as it is. So answer for this is A, B bar, D. So this is how grouping is done in 4 variable K map, and this is how the rolling of the map is done. Let us see K-map reduction techniques. Whenever K-map is given in the example, then first go for forming the bigger group. That means you first form the octet. If octet is not present in the K-map, then don't jump quickly to form the quad. Take the step that roll the map and try to form the octet. If that is not happening, then only go for quad. If you do not find any quad, don't quickly jump to pair. First roll the map and try to form the quad. If these two possibilities are not there, then and then only go for pair. If you do not see any pair, again you roll the map and try to form the pair. If all these three possibilities of pair, quad and octet are not present, then only you go for the last step, that is identify the ones which cannot be combined with any other ones and encircle them. We will see few examples on K-map in the next slides. Let us see first example. The equation is given in the form of minterms. The K-map is already filled for the respective blocks. Now we will follow the K-map reduction techniques. First we will go for the octet. If you see the K-map, you will not find any octet there. But don't jump quickly to the quad. First roll the map and check for the octet. Still octet is not there. Now we can go for quad. If you see it, you will find quad here. Now don't jump for the pair immediately. First roll the map and check for the quad. Now in this example, after rolling the map, we are not getting any quad. So we will go for the pair. Now you will find pair here. You will find pair here. And you will find pair after rolling. Now all ones are covered. Now we can write the answer. So answer for this K-map is, so for answer for quad is, it is BD. Answer for this pair is A bar, B bar, C. Answer for this pair is A bar, B, C bar. And answer for this pair is A, B bar, D bar. Let us see the next example. Now K-map is filled for that. Now we will go as per the K-map reduction steps. First we will see the octet. So octet is not present there. We will roll the map and we will check for the octet. Still octet is not there. Now we will go for the quad. We are not finding any quad there. But if you roll the map, you will find the quad. So after rolling, you will get this quad. And now we will go for the pair. Now we are having this pair here. We can form this pair. Now this one is remaining. We can form pair by rolling the map. Now we will write the answer now. So y is equal to, first we will write answer for quad. For quad, answer is A D bar plus answer for this pair is, we can say B C D. Answer for this pair is A bar B D, and answer for this pair after rolling is B bar C bar D bar. Now let us see the third example. Again K-map is filled. Now let us follow the steps. First we will go for the octet. Yes, we are getting one octet here. Then we will roll the map and check for the octet. So that octet is not there. Then we will go for quad. So quad is not there. We will roll the map and check for the quad. Yes, after rolling we are getting quad here. And then we will go for the pair. So plain pair is not there, but after rolling we are getting this pair. Now we will write the answer for this. So y is equal to, answer for octet is A bar plus answer for quad is, here we are getting B bar and here we are getting C bar, and answer for pair is, I will write pair here, plus it is A B bar D bar. Let us go for the last example. Again K-map is filled. Now let us see and apply the techniques. Octet, plain octet is not there, but if we roll the map we can get the octet here. So this is our octet. Then we'll go for, again if you check after rolling you will get one more octet with this one, and now all ones are covered. So there are two octets in the example. So answer for this example is y is equal to B bar for this octet, and for this octet answer is d bar. This is how we solve the SOP equations by reduction technique. Now we will solve the POS equations with the help of K-map. This is our POS equation in the form of minterms, and this is the K-map field for that. Keep one thing in mind, when we talk about POS or max terms, we put zeros in the respective squares, and we are going to group the zeros. We are going to follow steps as usual. First we will see the octet, so octet is not present for zeros. After rolling the map, still octet is not there. Then we'll go for quad. If you see the map, quad is not there for zeros. And after rolling the map, still quad is not there. So we'll go for the pair. So this is my first pair. This is my second pair. And this is my third pair. So I will write the answer as usual for the pairs. So y is equal to, answer for this pair is a bar, b bar, c, plus answer for this pair is a bar, b, d bar, and answer for this pair is a, c bar, d bar. But this is the answer in SOP. We have to make it POS. For making it POS, we have to complement this answer. So we will write it as y bar, and this equation a bar b bar c plus a bar b d bar plus a c bar d bar, and whole equation we have to put a bar. And to get answer of it, it's very easy. Do one thing: if there is a bar, remove the bar; if there is no bar, put the bar, and multiplication sign is replaced by addition sign, and addition sign is replaced by multiplication sign. What do I mean? Answer for this is, I will write that answer here, y is equal to, now here a bar b bar c, so I will write a b c bar, and I will put plus sign, and I will make a bracket for that. Now this plus sign is replaced by multiplication sign, and here I will write a plus b bar plus d, then I will put multiplication sign, and this term will be written as a bar plus c plus d. This is how answer is found for the POS. Go for the next example. Again K-map is filled. Quickly we will form the groups. If you see the K-map, no octet is present. Even after rolling, no octet is present. Then we can get quad there. So we'll form quad for this zeros. Then we are getting one more quad straight away for this. So there are two quads. So my answer for this is the quad answer for this, and answer for this quad is a c bar. Again we have to write answer in POS, so I will write it as a bar b bar plus a c bar whole bar. Here I am writing y bar. So answer when I write, so here it will be a plus b into a bar plus c. Go for the third example. K-map is filled, and follow these steps as usual. First see for the octet. Yes, octet is present, so this is our octet. Then roll the map and check the octet. So octet is not there after rolling. Go for the quad. Yes, there is a quad present. After again roll the map and check for quad. Then no quad is present. And now go for pair. So we can get pair after rolling only. So answer for this is, for the octet, answer is C bar. Answer for quad is B, D. And answer for pair is A bar, B bar, D bar. Now in POS we have to complement. This is BD plus A bar, B bar, D bar, whole bar here. So answer is finally C into B bar plus D bar into A plus B plus D. Go for the last example. So K-map is filled. So check for octet. So octet is not there. Roll the map and check for octet. Still octet is not there. Then now go for quad. Yes, straight away we are getting two quads there. This is one quad and this is the second quad. So answer for this is y is equal to, answer for this quad is CD, answer for this quad is AB. Then we have to do y bar is equal to CD plus AB whole bar. So I will write that answer here now. So y bar is equal to C bar plus D bar bracket into A bar plus B bar. This is how POS equations are solved with the help of K-map. Now we will learn the concept of don't care condition in the K-map. Whatever Boolean expressions we have seen, all are completely specified. That is, for each combination of input variables, there is output. Sometimes cases may arise where input does not happen or the input happens but output is ignored. The condition for which we do not have any output is known as don't care condition and it is denoted by X. We will understand this concept in the next slide. Let us understand don't care condition. The input does not happen. What does it mean? Let us see this question. Suppose 4 bits are used to represent a month. The output is 1 when there are 31 days in a month, else output is 0. Let us form truth table for this. A, B, C, D are the input combinations and Y is the output. This is the month January to December. January input combination is 0000, output is 1 because there are 31 days in a month. February 0001, output is 0 because there are 30 days in a month. Like that, table is completed. Now let us have a focus on these four conditions. Because these four conditions, they are not going to happen. Because there are 12 months, so our truth table ends here. So what should we write output for these conditions? The output which is written for this condition is known as don't care. That means output can be 0 or output can be 1. It doesn't make any difference because these conditions are not going to happen. Let us see the K-map for the truth table. The 4 squares are kept blank and these blank 4 squares we will put there don't care. This K-map is formed from the truth table. Now suppose we want to solve this K-map. So what is our answer for this K-map? See, here I can form the quad by rolling. I can form the pair here and I can form the pair here. So answer for this K-map is, answer for quad is A bar D bar. Answer for this pair is A bar B C. And answer for this pair is A B bar D. Now what is the significance of don't care? If we use don't care to more simplify your equation, then use it. What I mean to say is, don't care I can take 1 everywhere. Now see, this is my answer without taking don't care. Now if I use these 3 don't care conditions out of 4, I can reduce my answer. Let us check. Now here I can form a quad instead of pair. And here I can form a quad instead of pair. Then what is my answer? So first quad is as it is A bar D bar. The answer for this quad is B and C. Answer for this quad is A and D. Now this answer is reduced, so because of don't care conditions. If your answer is getting reduced, that means the number of gates which will be required will be less and cost will be less. So if don't cares they are helpful, use them to reduce. If they are not, then don't use them. Take one more example. Suppose 3 bits are used to represent the days of a week. If day contains 6 letters, then output is 1. Else for rest all condition, output is 0. So this is my truth table and these are my days, Monday to Sunday. Monday has 6 letters, Friday has 6 letters in it, and Sunday has 6 letters in it. So output is 1 for them, and for other days output is 0. Now again see, this condition is not going to happen. So output for this condition is don't care. Now let us go for the K-map for this truth table. Now see, the don't care condition is put here for this one. Now let us solve the K-map. So this is one pair I am getting and this is one pair I am getting. So my answer for this pair is A C bar and answer for rolling pair is B bar C bar. Now suppose I use don't care. Now using don't care, I am increasing one pair. So my answer would be these pairs are as it is and this pair is increased. So answer for this pair is AB. Now without don't care this is my answer. With don't care this is my answer. So this answer instead of getting reduced, one term is increased. So don't use the don't care. So don't cares are used when your answer is getting more simplified. We will see the next condition in don't care in the next slide. Let us see the second case where a don't care condition happens. Here it is written the input happens but output is ignored. Let us understand this with the help of one example. Consider a circuit which produces a difference of two numbers when second number is less than or equal to the first number. Let us draw the truth table for it. We are having two inputs A, B and output is Y. Now what question is saying, so the circuit will produce the difference of two numbers when second number is less. Here second number is less than the first number, so I will get the difference. Or equal to the first number. Here second number is equal to the first number. Here second number is equal to the first number. So here I will get the difference. So here it is 0 and this condition is not specified. So here I have to write the don't care. Now I will fill the truth table for this. So this is my A, this is my B. So this is my A bar, this is A, this is B bar and B. Let us put the values from the truth table. This is 0, this is X, this is 1 and this is 0. If I don't use don't care, so only 1 is there and answer for that one is A, B bar. If I use don't care, then don't care is not reducing my answer. Unnecessarily one more term is increased. That means this term is as it is. And for this, we are getting the answer A bar B. So instead of getting reduced, it is increasing. So we are not going to use the don't care in this case. Let us take one more example. Here, in this example, what is written? Consider a 3 input circuit where output is 1 when out of 3 inputs, 2 inputs are 1 and output is 0 when all inputs are equal. Let us draw the truth table. What it is saying, out of 3 inputs, when 2 inputs are 1, these are the conditions. Here out of 3 inputs, 2 inputs are 1, then output is 1 and output is 0 when all inputs are equal. So this is equal, so output is 0. This is equal, so output is 0 and remaining conditions are not specified. So output is don't care. Here in both the truth tables you check. Here what we can say is in this truth table and in this truth table input happens but output is ignored. That was not happening in the previous slide. Now let us draw the K-map for this. Here in the K-map, we are going to get, see here in the K-map, this is 0, this is don't care, this is don't care, this is 1, this is don't care, this is 1, this is 1 and 0. Now without don't care, my answer would be 3 single ones. So we cannot form pair or quad. So answer for this one is A, B, C bar. For this one is A bar, B, C, and for this one is A, B bar, C. Now if I use don't care, then let us see it is reducing or not. Suppose I use these two don't cares. Suppose this don't care is used and this don't care is used and this also it is used, then I can form say straight away pairs. So this is there, this one is one more pair and this one is one more pair. So answer would be now for this pair it is B C bar. For this pair it is now A B bar, and for this pair it is now it is A bar C. Now this answer is definitely getting reduced. So all the don't care conditions are used here. This is what is the concept of don't care condition. Let us have practice of don't care with one more example. This is our example given. It is a 4 variable K map having minterms and don't care condition in the square 5 and 9. Let us make K map for this. This is our K map for the minterms and don't care. When we solve the K map, first we will solve it without don't care condition and we will see the answer. So here in K map I am getting one quad, then I am getting one pair by rolling this, I am getting one pair by rolling this, and I am getting pair here. So my answer for this K map is y is equal to answer for quad is CD, answer for this pair is B bar, C bar, D bar, answer for this pair is A bar, B, here it is D bar, and answer for this pair is A, B bar, C. Now suppose I used don't care condition, both the conditions. Then if this is 1 and this is 1, then straight away I can form a quad here. Here again I can form a quad. And now this one is only remaining, so this pair is as it is. So answer after using don't care would be, see this CD as it is, plus answer for this quad is A bar B, answer for this quad is AB bar, and answer for this pair is as it is, that answer is B bar, C bar and D bar. If you see these two equations, this is without don't care and this is with don't care. So you are finding with don't care more reduced answer. So we are using both the don't care conditions. So in nutshell, we can say that if don't care conditions are there in the example, if they are useful in reducing your equation, then use them. Thank you for watching my video. Please share and subscribe.